Okay, good afternoon, everyone, and welcome to today's webinar with Eaton. We'll give the others a few moments to log in before we begin. Right, I think we should start. Hello, everyone, and welcome to today's webinar with Eaton on switching to SF6. My name is Yin, and I'm the Marketing Executive at Rexel. Before we start, I've just got a couple of things for you to take note. Firstly, this is a recorded webinar, and the video will be available to watch on demand on the Rexel website. This webinar is also CPD accredited, and the certificates will be sent directly to the email address you registered with for the webinar, and this can take up to 4 to 5 weeks to arrive. If you have any questions throughout the session, please feel free to pop them into the Q&A bubble, which you can select from the menu on the side, and we'll answer them at the very end. Today, I am joined by Paul Wakefield, who is the lead applications engineer for Eaton, and Darren Ingram, the project sales engineer. I'll now pass the time over to Paul and Darren.
Thank you.
Yeah, thank you, Ian, and welcome all, and of course thank you for taking the time out of your busy routines to participate in this session. Thank you to Rexel for hosting to make this possible, and to our marketing colleagues for helping put the presentation together. We hope you gain some valuable insight into the transition to SF6 solutions from MV switchgear, and why now is the time to be considering this. As you may be aware, the regulation changes on deployment of SF6. We'll discuss the outcome of the review and what this means at a European and country level, and the next steps for manufacturers and operators of equipment. So let me begin by introducing myself. My name is Paul Wakefield, and I'm an applications engineer with a focus mainly on MV systems up to 36 kV, but incorporating transformers and substation solutions. I've held many roles throughout my career. As it notes in the panel there, I just celebrated 45 years service, beginning at Bill Switchgear, Delta Electrical Systems, which was then acquired by Eaton. So one thing's for sure, after 45 years, I'm still learning. I'm joined by my colleague, Darren Ingram, who is an account manager and project sales engineer. He's based out of the Slough offices, but like many today, probably work from home. He joined Eaton in 2004, so has got a wide experience in project sales, and he's our lead for large project works within sectors such as healthcare, military, commercial, industrial, and education.
Thanks, Paul.
So this is the agenda for today's presentation. Firstly, we'll consider the F-gas regulation changes. which is the phasing out of SF6 from switchgear. Why have the regulations changed? SF6 being a highly potent gas, which has environmental implications. What should utilities and asset managers consider now? That being the regulatory changes, key components and its implications. What needs to be done to SF6 to switch to SF6 free? Obviously, there may be differences in the equipment, and so this considers the next steps for the transition. And also, we finally would just like to give a little more of a flavour of what Eaton can do as a partner on SF6 free switchgear, as we do have a proud history in being SF6 free for a considerable time. So, moving on to the F-gas regulation changes. In March this year, the new regulations came into effect. So let's look at the F-gas changes. So here's the timeline for the regulation. From the timeline, you can see that today, 2024, these include rigorous leakage checks, particularly for users above 6 kilograms of gas. The implementation of advanced leakage detection systems, meticulous record maintenance protocols, and recovery and destruction, and 45 regulations to extend producer responsibilities. January 2026 sees the ban of SF6 sales on new switchgear. This is up to and including 24 kV, which is probably the dominant voltages for medium voltage in the UK. 2028 sees the ban for 52 kV to 145 kV. And then in 2030, again, moving back towards a popular voltage level within the UK, 33 kV, the F-gas phase out and ban begins in January 2030. So as we move forward, we'll uncover what's driving this change, what's happening now, and what lies ahead. My colleague Darren will cover the next section. Thank you, Darren.
Good morning, everybody. Yeah, thanks for taking the time to join this CPD. So what we're going to look at, why the F-gas regulations have changed. Next slide, please. So sulfur hexafluoride, or SF6 as we know it in the industry, is a synthetic gas. It's colourless, it's odourless, it's non-toxic, it's non-flammable, it's chemically stable, and it has a high dielectric strength, which makes it a prize electrical insulator, particularly for medium voltage and high voltage insulators. So it's not uncommon that we still see this used as a dielectric. It's been used as the dielectric for many years. SF6 has been a crucial component really for us in the electrical industry, and instrumental in preventing short circuits and accidents, acting as an interrupter medium to quenching our arcs within our MV switchgear. And this ensured reliability and efficiency of electrical equipment for many years. And most importantly, it's been a key player in safeguarding the flow of green energy across our grid. So it's had its point in time, and it did us justice up to this point. Next slide, please. So with all these attributes, what's the problem with using SF6? Well, the fact is that SF6 itself is highly efficient in switchgear, as I just mentioned, as an insulator, but it significantly negative impacts the environment, which is prompting us to explore sustainable alternatives. The global warming potential, as you see on the screen, of SF6 is 25,200 times stronger than that of CO2 over a period of 100 years. And since this is a human-made product, it can't be destroyed and naturally remains in the atmosphere for more than 3,000 years after being released. And obviously a significant contribution to greenhouse gas effect and therefore climate change. In addition, though, SF6 is not a toxic gas. There are health and safety issues concerning the toxic byproducts that result from the arcs discharges and sparks using SF6. When we switch in SF6, it becomes a carcinogenic. And you'll see in the diagrams of the studies above that the releases SF6 raised and raises nowadays, and this is why the ban is coming into effect soon. Next slide, please. SF6 has been used in a wide range of everyday products, not just in switchgear as a dielectric, but due to its effect on global warming, which, as we mentioned, several 100,000 times stronger than CO2. In the 2014 update of the F-gas regulation, the EU banned the use of SF6 in manufacturing many items such as tennis balls, which we don't know that they're in there, sports shoes, car tires, and our double glazing at home. However, it was decided against banning SF6 in switchgear, claiming no widespread, cost-effective, technical, feasible, energy-efficient, and reliable alternatives existed. This decision led to the fact that most of the total SF6 annual emission in the following years comes from switchgear installations. The world's growing energy needs require expanding our grids and installing more switchgear. For instance, in Germany, studies predict that switchgear installations will double in the next 30 years. And without regulatory changes, this means a nearly twofold increase in the SF6 emissions into the air during that same period. So it's something that we've got to be very prominently aware of and something that we need to react against. Next slide, please. So if we consider that 80% of FS6 that we use today comes from switchgear installations, making it the best loophole for SF6 gas, which is obviously why the regulation needed to be changed. And therefore, these impact, these changes, these dates that are being enforced are going to help us identify this problem, see this problem, and decide what we do next. Back to you, Paul.
Thank you, Darren. So what should utilities, asset managers consider now? Well, I guess it's not just applicable to these parties. Any facilities managers or investors, perhaps particularly around PV, battery storage installations, all have a part to play in this consideration. So switching to SF6-free and the benefits. SF6-free alternatives are not only regulatory requirement now, but also have an environmental and financial consideration. When evaluating the costs, it's crucial to consider both a long-term financial implication and the effects on the environment beyond the initial investment. We must delve into the total cost of ownership, TCO. In comparing SF6 switchgear with SF6-free alternatives, the total cost of ownership calculations should encompass the comprehensive range of factors, including purchase price, installation costs, maintenance expenses, operational costs, energy consumption, and the end of life disposal. Additionally, we must take account of the potential costs associated with the environmental impact and regulatory compliance, providing a confident and accurate financial analysis. You can see there that Eaton have a TCO calculator available. An in-depth analysis reveals that while SF6 equipment may seem cost-effective initially, the SF6-free alternatives exhibit a significant lower total cost of ownership over their entire life cycle, providing a reassuring financial advantage. This advantage stems from reduced maintenance costs and diminished needs for replacements. Moreover, SF6-free alternatives contribute to a lower environmental footprint and align with global sustainability objectives, mitigating regulatory and reputational risks. Transitioning to the SF6-free solution supports environmental goals and ensures greater predictability in long-term operational expenses, motivating a positive change. So, as we mentioned in previous slides regarding the regulation updates, SF6 transformation is underway now, and here are the key components for consideration. So, the phase down mechanism. The regulation introduces a phase down approach to gradually reduce the quantity of SF6 placed in the EU market, lowering the allowable amounts over time. This mechanism directly targets the supply side of SF6, aiming to decrease its use in all sectors, including the application in PV parks for electrical insulation and arc quenching. Companies must explore SF6-free alternatives to comply with these reduced quotation limits. This may be applicable to switchgear that, whilst it's not failed, it's also reaching its end of life and should be replaced. There are many solutions available currently up to 24 kV. Secondly, leak prevention and reporting. The regulation tightens the requirements on leak prevention, imposing stringent requirements for monitoring, reporting, and reporting leaks of SF6. This aims to mitigate the environmental damage caused by these leaks and encourages adopting best practices in handling and maintaining equipment containing SF6. There's an obligation to report leaks and report the amount of gas used. Only switchgear which is type tested and proven to be less than 0.6% leakage is exempt from this. Thirdly, training and certification. The regulation mandates more stringent training and certification requirements for personnel installing, servicing, maintaining, and decommissioning equipment containing SF6. This ensures that those handling SF6 are adequately skilled in leak prevention and proper gas handling techniques. Organisations may be required to hold certifications demonstrating their compliance and best practices for managing SF6, including the use, recovery, and disposal. At end of life of installed equipment, the SF6 gas needs to be removed. Also, some systems require the gas to be topped up, particularly on older products. This is part of the total cost of ownership that we should take account of. And finally, investing in SF6-free technologies. Preparing for changes and switching to SF6-free alternatives is not just about regulatory compliance, it's about leadership in environmental stewardship. By anticipating and adapting these regulations, businesses can be front runners in transitioning to more sustainable practices. Being ahead of the curve has tangible benefits, including reduced environmental impact, enhanced corporate reputation, and alignment with global sustainability goals. These technologies are available today. In fact, in some countries, there are tax efficiencies and subsidies for encouraging the change. Now is a good time to reach out to manufacturers with SF6-free solutions. I'll hand back over to Darren now.
Thanks. So what needs to be done for us to switch effortlessly to an SF6-free environment? And let's look at some of those points. Next slide, please. So it's important to say that, as Paul pointed out, we need to act now with everything that comes into supporting climate change. So, we're encouraging our customers, our many customers up and down the UK and in Europe, to start looking at SF6-free equipment, and not wait until that final minute where the regulation comes in, and you need to understand where it is, how big the unit is, what does it look like in comparison to a traditional SF6-free equipment. According to the Green Public Procurement Rules, they're already saying that we're actually part of flow, and that we need to give more focus. So we're promoting our customers to look at their tenders to see if we can offer an SF6-free solution, generally up to 24k, sometimes beyond, as an alternative to their market. And besides tendering new products with SF6 gas, we should look into the existing portfolio that our customers have as well. And we're asking our customers to audit their inventory, to look at their footprints for any systems that are potentially coming to the end of life. And as they are coming to their end of life, what do they need to do? Well, as we said before, it's a carcinogenic gas that's produced after switching in SF6. So we need to make sure that you take proper care of gas handling at the end of life and understand how you safely get rid of that. Where does it go? As a customer, you're responsible for getting rid of the gas. So you need to pay attention to recycling options. Who do we need to have look for responsibility for removing some of this kit, and check existing footprints for switchgear that's on the plants, and see how, when it needs to be changed, and whether we can instigate change on that switchgear now rather than us waiting for the implements to change with regards to the regulations. Next slide, please. Ultimately, we're trying to encourage change here, guys. We're all responsible for it, and we're trying to encourage our customers to move away from any other design perhaps that they were looking at in a traditional MV format, trying to help train staff for them to understand what SF6-free solutions look like. They're not very dissimilar to that's available with an SF6 product, almost identical, and not much change in physical size either. So we're trying to speak to our consultants, speak to our end users, and try and get involved in early design to ensure that they're aware of the advantages, not just in a climate environment, but how their customers see them by supplying a non-SF6 free piece of equipment into their buildings. So we're preparing for a cleaner, greener grid, and the way that we can do that initially is by taking our inquiries and seeing how we can offer an alternative. So reach out to the SF6 free medium voltage switchgear manufacturers. It's not just Eaton, there's many of us out there now. Everybody's on catch up trying to get products out onto the market that don't contain SF6 free, that have SF6 free technologies. So, you know, choosing the right technology, start implementing perhaps some pilot projects, ring your manufacturers and understand the applications of the project that you're working on and how SF6 free switchgear could be a solution, and to learn and gain experience from it and see the behavior with regards to our design, how we put it together, what we can claim. And as Paul said, all part of end of life. Once these are decommissioned, we have to consider how you're going to get rid of them, and we don't have to take into consideration many steps on maintenance by having an SF6 free solution. So it's promotion. That's what we're trying to do today. We're trying to promote the picture that SF6 is a bad product. It's going to be dismantled over time. The dates are changing for it now, so we want to be ready. I think it's back to you, Paul.
Yes, thank you, Darren. So the final part of the presentation is just highlighting what Eaton can do in this changing environment. There are many technologies available on the market. Eaton has a proven partner and history in SF6 free solutions, certainly up to 24 kV. Many of our systems are within sealed tanks with air, so there's no over pressure where you may need to have staff trained on dealing with pressure-filled vessels. It's basically air within a tank. We put the equipment in a tank not to stop the leak of gas, just purely to keep the product inside safe from moisture and any other environmental effects. Eaton uses predominantly solid insulation, cast resin parts, which are minimizing the risk of internal arcs and flashover. The materials are non-toxic, which aid to the recycling costs at the end of life during disposal. Looking at the timeline on the next slide, as you can see, Eaton has a long history in the manufacture and supply of vacuum interrupters. We have 2 plants supplying vacuum bottles worldwide, and those are Eaton plants with Eaton designs. Eaton has had a compact SF6 free switchgear product available for many years. We were, as we very often mention to customers, that we were almost a niche industry, but obviously more recently that that angle has changed considerably. In the 1960s, we launched the most compact SF6 free ring main unit in Europe. In 1989, we introduced metal-clad SF6 free switchgear, and more recently, you can see on the timeline in 2002, we launched the Ziria range, which is a compact ring main unit, SF6 free up to 630 amps, 20 kA up to 24 kV. Earlier this year, we launched an enhancement to that product called Ziria NGX, which is up to 1250 amps, 25 kA, and again 24 kV. And we have plans in place to bring out 36 kV switchgear products to meet the imposing timeline for January 2030. We hope to be well in advance of that. So we're pioneering solutions, and we pride ourselves as being the original manufacturer to introduce SF6 free technology. Eaton has been pioneering the SF6 free medium voltage switchgear, as you can see, since 1960, and offering those green solutions to the modern day and for future energy challenges. And finally, in closing there on that, Eaton's mission is to improve the quality of life and the environment through power managed technologies and services, and we are accelerating the transition to renewable energy. So, final slide, which is just what Eaton can do to support that change. As we've been in this particular SF6 free market for a long time, we've got lots of documentation and technically supporting information, white papers, if you like, on various product groups. We've got extensive libraries of what we've developed as standard products, which are available, which we share willingly. We can provide training for personnel on operation, installation and maintenance of our products. And yes, all Eaton switchgear is fully type tested, and furthermore, we go one stage further and have those tests independently witnessed by third parties. So it's not just what we say, that's backed up by independent certification, KEMA, for example. And finally, we have lots of standards that have accrued over the years, but we can also offer a tailor-made solution, for example, with clients having particular protection systems. We're not precious about the protection relays that we use. If a customer has a particular style, then we're more than happy to consider the integration of such products within our low voltage assembly or low voltage compartment within the switchgear. Thank you very much for paying attention, and we hope it's been informative, and invite any further questions or clarifications that you may have at this time.
Thank you, Paul and Darren. That was really insightful and informative. I hope everyone has found it useful. We'll now jump into the Q&A time. Just a reminder, if you do have any questions, you can type them into the Q&A bubble and that will come over to us, and we'll follow up any unanswered questions via email. So we had one that came through really early on in the session, asking what about 11 kV?
Okay.
Yeah, well, as we've mentioned in the slides, we have systems available today for fixed, withdrawable, demountable at 12 kV or what is 17.5 kV system, right the way up to 24 kV. That includes systems up to 50 kA, 4,000 amps. So not just secondary equipment, we can also provide solutions for any particular requirements. We've got most base covers up to including 24 kV at this time.
So full range, in 11 kV is covered within our portfolio, and if you need any further information, we can speak to the customer or speak to the person that's reached out, and we can supply them with some more information.
If you do need any more information, then just contact marketing@rexel.co.uk and I can forward it on to Paul and Darren for you. Another question, how do we dispose of SF6?
So it's a good question. Generally, when we look at switchgear itself, the makeup or the fabric of the switchgear is generally recyclable to a certain point, but it's the disposal of the actual gas itself, and that'll be taken on by specialist contractors to take the bottle of the SF6 out. Funny enough, me and Paul we were on an RAF base, and there is some SF6 free switchgear on there at the moment. So we have to bring in a specialist contractor to take the SF6 out before the services team will start to dismantle the switchgear. So again, we can give you contacts for who you might want to contact for that as specialists. It's a bit like any substance, if you like, that's dangerous or illegal. You will need a specialist contractor, but we can put you in contact with them, and we can give you the protocols of how we'd suggest you start that system of getting Eaton involved, or another manufacturer to come and have a look at the switchgear to see how many sections it is, to see how old it is, to pull the drawings out, to see what the actual switchgear contains with regards to any gases or materials that we wouldn't normally use anymore. And then we would put a program together to understand how we dismantle and how to get rid of that. But it will be a specialist contract that actually gets rid of the actual bottles themselves.
Yeah, so yeah, just to highlight what Darren has mentioned, you know, we talk about total cost of ownership a lot in the presentation, and obviously this for anyone who has an installed base of SF6, then this is obviously now requiring certified, authorized people to be able to remove SF6 and to dispose of it in, you know, the appropriate manner. That's something that you don't see when you have SF6 free or gas free equipment. You're just dealing with the recycling of materials rather than, you know, exposing people to potentially harmful elements.
Just a couple more. Can we continue to use this gas going forward?
Darren, I don't know whether do you want to take that, or we can chip in as we go.
2030 is the limit for 24 kV. I think that's right, Paul, up to 24 kV.
No, so as of January 2026, the ban is enforced. So all new products up to 24 kV need to be SF6 free. The highlights from the slide are such that now there are stringent checks, if you like, and controls around the use, but it's not effectively banned until till January 2026, and that's really the message that we're encouraging now, is for pilot or investigations to see what the options are. And it's the Eaton logo is there, but it's not just Eaton, there are other suppliers, but the message is that we need to encourage people now, businesses, investors, to look at SF6 free solutions, that they're out there. Yeah.
We find that our government projects, they've already switched over, and they already come into us and they're saying that they won't buy anything but a non-SF6 or SF6 free product. And as Paul said, now is the time. It's 2026, but that's going to approach before we know it. So we have got to start, considering the designs now, because by the time they come to fruition, we really need to be quoting and tendering for them type of jobs now, because they're probably a year off of manufacture, and before we know it'll be 2026. The next big change will be then for the 30 above 24 kV, which is 2030, and in 2030 switchgear above 24 kV up to 36 kV will require non-SF6 free switchgear as well. So a little bit longer on the higher ratings, but that's why we're pushing to talk to it now and engage with our customers, because the designs will take a year on most occasions, at least, to come through. So if we don't start talking about the designs with it now, by the time you come to fit the switchgear on site, it needs to be non-SF6, but for under 24 kVA by 2026.
Yeah, and just to echo that fact, obviously at 36 kV, there are solutions available that are SF6 free, but they tend to be much larger because of clearances that are required. Whilst Eaton have an SF6 free solution, it's quite large currently, because it's an air insulated withdrawable system. But watch this space.
Yeah.
Just got one just come through. We can plan, but is there an end date of current SF6 in use?
Oh, do you want to take that one? I think you've answered.
So an end date. So as we say, yeah, the ban up to 24,000 volts will come into place January 2026. With certainly in the UK, okay, there are higher voltages, but the higher voltage, the plan is 2028, but 36 or 33 kV is a common primary voltage, and manufacturers have until January 2030 when the ban comes into place for up to 52 kV. So it's coming, so we all need to be prepared for that.
The 11 kV, everybody's got to start looking at non-SF6 in short. and by 2030 or 2028, we've got to start looking at not using SF6 free product in units above 24 kV up to 36. It's a bit of a different market once we get up to the higher ratings, the 33 kV, the 36 kV. Many times we look at our public companies and our Ministry of Defence, and they're looking at solutions where they're giving us the option to look at 11 kV, 24 kV, because they know that that's a product that's widely available in the market. Whereas they're making it a bit more lenient on them at the moment, using 36 kV, using a 36 kV or 33 kV solution for switchgear that has still got SF6 in it, only for the fact that everybody's still developing products that are small enough and manageable enough so that the changeover on these higher voltages, they can still fit the kit in the room. Hence the slight delay on the 33 kV, but they're pushing the 24 kV to 2026. Let's get that one sorted out first, stumped in the ground. You know, you won't be able to buy any more 11 kV, 24 kV by then. And then we'll look at the next problem, which is 33 kV, and everyone's trying to find the solution for that that's small enough to fit into an existing building.
Yeah, on that point, I think there are some sort of other alternative gases that have been trialled, but at the end of the day, they're not SF6, but they're not as clean as an air solution, so they still have a gas which, you know, potentially will certainly be more harmful than CO2.
Thank you. I hope that answers the question there. Don't think we've got any more, but if you do think of any after the session, then please do send them over to marketing@rexel.co.uk and I will forward them on to the experts for you. So I think that's about time for today. Thank you everyone for joining. Thank you Paul and Darren for your time as well. Just a reminder that the CPD certificate will be emailed directly from CPD, and that will take up to 4 to 5 weeks. Thank you once again, everyone, and we look forward to having you in our future webinars. Thank you.
Thank you. Bye-bye.
Thank you all.